Okay, welcome back to this part 3. So we're going to carry on. I think if we can just complete the whole question paper. Okay, so it's question 3 says 3.1, observe the sequence of figures below. 3.1.1, describe the pattern in words. How can we describe this pattern in words? Well, we can just say that here we adding. What do we have here? First of all, these figures, we can count how many matches. There are 3 matches. Okay, this is 3. What is going on here? Why I'm not able to? Oh yeah, I need to take the pencil. So I've got 3 here. I've got 5. I've got 7, and here I've got 11. So what is happening in this sequence? So can we agree that we are adding 2 to get the next number, right? So in Word, we can say add 2 to get the next number. I think the keyword here is add 2, okay? Or what else can we say? We can say we are counting by 2, starting from 3, counting by 2, starting from 3, okay? So, okay, 3.1.2, it says find the general term for the pattern. Okay, right. Let's come this side here on the right. We said that here, in this pattern, we are counting by 2. But in primary school, how did you learn to count by 2? Well, you said 2, 4, 6, 8, 10, 12, and so on. That so on basically is a general term. We can say, because it's counting by 2, is basically 2n. Okay. What is it counting by 3? Is 3, 6, 9, 12, and so on. The general term of counting by 3. So it will be 3, 6, 9, 12, 15, 18, and so on. The general term of counting by 3 will be 3n. But in this case, we are right here. We are counting by 2. This was just an example. Okay. So let me just delete this. Don't need this part. It's just showing you. So now, this is how you solve it. So the first step, you need to write the original counting by. The original counting by 2 starts with 2. Okay. And now we can write the sequence that we have here, just below it. So the sequence we've got below it is also counting by 2, but we're starting from 3. So it's 3. We add 2, it becomes 5. We add 2, it becomes 7. 7. Then the next one is 11. So how are we going to express that? Is it also 2n? It's not 2n, but it's going to be 2n, but we must have something here, okay? What is happening to this 2n? Is this the original 2n, but we always add plus 1 to get the term. We get plus 1 to get the term. So you must also add, you have 2n, but to get to the one below, you must add plus 1 here. Can you see the third term? You've got 6, but the corresponding third term of this sequence is 6 plus 1. And so on. So, okay, so I was wrong here. The next term, was it 11? No, it's a mistake here. It wasn't 11, it was actually 9. So here it is 9. Sorry, this was 7. Here we've got 9 matches. likewise as well. It's good to make mistakes like this so that you know that this is how you can make mistake, but then you have to fix it, right? So we got 3, 5, 7, 9, right? Because it's always plus 2. 7 plus 2 is 9, not 11. 7 plus 2 is 9, and then plus 2 is 11, plus 2 is 13. So from the first line to the other line, the difference, we just add whatever we have got here and we add 1, right? So this will be the general term. So the general term, Tn, will be counting by 2, because you are counting by 2, it's 2n, and then plus 1. So that's the trick. Basically, what is the trick here to find the general term? If you've got, let's say, you've got a sequence like, suppose you've got 2, 5, 8, 11. Okay, so can you see it's always plus 3 to get to the next number, right? So the general term of this sequence is already 3n, right? But remember the original 3n sequence counting by 3, you always start counting by 3. Like in primary school, you see 3, 6, 9, 12. Now you're going to compare. So this is the original 3n. But what is happening from the original 3n to the corresponding 3n? Can you see is always you subtract by 1. You subtract by 1. To get this, you have to subtract by 1. So it means the general term of this sequence will be 3n minus 1. So I just gave an example to find the sequence, the general term of this sequence. So it's actually 3n minus 1. This is how you think about it. Okay, let's not waste much time. Let's move to the next question, 3.2. So let's move everything up. 3.2. Okay, so here, study the flow diagram below. So, on the left, we've got what we call the input, right? The input represents the x. And then on the right, we've got what we call the output. So these are the y's. And right in the middle, we've got the rule. So in this case, it's a function. So this is the rule. And the rule basically maps the input for us to obtain the output. Okay. So how many rows have we got? We've got 3 rows because we've got 3 inputs. Subsequent to that, we've got 3 output. So how do we rewrite that? So let me just draw a line to move to this question. Basically, the input basically represent the x. What do? I can just write the rule. So the first row, what I've got, I write the rule, but everywhere I see x here on the rule, I'm going to replace it with the input I see here, because the input, that's the x, right? The x value. So I write the rule is 2 times, instead of x, I'm going to write the brackets to reserve a space for x. So it's x squared plus 1. So what do I have to put in there is basically the input. In this case, my input is, so you can see right here. Let me just show you here where we are. So you take the minus -3 here. We need to put it inside our bracket right here. Oh, I just deleted, sorry. So this is what we got. And this rule, by plugging the input, it needs to give us the output y. What is y here? Okay, let me just reserve a square bracket where I'm going to save y. So the value of y here is what? Is 19, right? So that's basically what it means. But in this case, we don't need to solve because we were given the input and we were also given the output, right? Okay, let's go to the next one. The next row. Let's write again the rule. So it's 2 times, let's reserve the space, squared plus 1 equals, let's reserve the space for the output. So what is my input here, right? This is my input, it's -1. And then what is my output? My output is right here, it is A. Okay, right? So now I can rewrite this same exercise. So this exercise is basically, it becomes 2 times, what is -1? Everything squared, it's basically 1, right? Because -1 squared simply means -1 times -1. And then negative times negative becomes positive. So positive, and then 1 times 1 is 1. So I first multiply the sign, which is positive, then I multiply the number, 1 times 1 is 1. So +1, basically it is just 1 here, right? Plus 1 equals A. Okay, so now we can just solve for A. So we solve for A, right? So what is 2 times 1 is 2 plus 1 equals A. And then when we solve the left hand side, we have 3 equals A, and that's basically the answer. So A, the answer here for A, so basically the output will be equals to 3. Right? Okay, now let's move to the third row of this diagram, the flow diagram. So we've got the third row here. So again, I'm going to start writing the rule. So it's 2 times, I reserve the space for the input squared plus 1 equals the output. In this case, the output is 9, right? So what is the name of my input? My input is called B, right? So what do I have? How do I solve this? Well, so I'm going to have 2b squared. So can I bring this plus 1 on the other side, so it becomes is equal to 9 minus 1. Okay, so it becomes negative. So what do I have? Remember now here we are solving actually for B. Solve for B. And now what do I have here? So we have 2b squared equals 8, right? So there's a way to do that. If you want, you can just bring everything to the left and then you equal 0 and then you factorize. I would have done that maybe a long time. I could have done that a long time. So then I'm going to have 2b squared minus 8 equals 0. Now, if I factorize this, so I'm going to have 2 factor of b squared minus 4 equals 0. And here, factorizing, this is the difference of 2 squared because 4 here is like 2 squared. I'm going to have 2b squared minus 2 squared equals 0. And it's easy to factorize the difference of 2 squared. So I'm going to have 2b minus 2 factor of b minus plus 2. Okay. When you have the difference of 2 squared, you factorize it by getting the conjugate. It gives you these conjugate factors. So what do we get? So basically we get now 2 answers, right? Because what would be B? Right? So b will be, because 2 cannot be 0, right? So it's either b minus 2 is equal to 0 or b plus 2 equals 0. So the answer would be b equals 2 or b equals minus 2, right? I think that is the answer. So let's just double check again. So everything is fine. So this was our rule. We had to plug the input, and from the input we just worked it out. Okay, so we've got 2 answers. Okay, great. I think that was this question 3.2. I think now we can work on 3.3. It says factorize fully. Factorize the following fully. So we've got this. Can we pick up here, right here, that we also have the difference of 2 squares? Let me just use this space here to solve this. So this, the first thing you do when you go to factorize is always try to find a common factor. Do I have a common factor between x squared and minus 16? No, I do not have. Then the next question I ask myself is, do I have a binomial or do I have a trinomial? In this case, I have a binomial. Can you say I've got one monomial there, the other monomial here? So this is a binomial. If you've got a binomial, you need to ask if you've got a difference of 2 squares. Well, I can see that x is already explicitly written as a squared, but minus 16 can be written as 4 squared. Once I can express them as squares, then it becomes more easy. It means I've got the conjugate factor. So the answer will be x minus 4 factor of x plus 4. So this is the answer. So we've managed to factorize the first one. Now let's move to the second. We are done with this. The next one, 3.3.2. Again, when we need to factorize, we first ask, do I have a common factor? How many monomial I've got here? I've got 3. 1, 2, 3. Is there factors that are common? Well, I can factorize minus. I put minus. What about any number? Here I've got 1, here I've got 8, here I've got 20. So the common factor is 1. So I don't need to really write 1. What about b? Yes, the common I've got b squared, and b. Let me start first with a. I've got a, and a. So I've got a as a common factor. Remember, I've got a bracket here. What about b? I've got b squared, and b squared. So I've got b squared. So this could be our qualifying common factor. Let me just delete it to write correctly my 2. So I've got minus ab squared. Now, as I factorize with the first term, what do I get? I get x squared here. So when I divide, so I need to divide this monomial by this common factor. So I'll have minus. I'm going to get 8x, right? Plus 20, right? So I factorize it. Now, is it fully factorized? Remember our question, they say we must factorize fully. So this is, we factorize. This is our common factor. But in this other factor, I've got a trinomial and it can still be fully factorized. Because when you've got a trinomial, you need to see if the middle term can be broken as can be an addition of two terms such that when those terms are multiplied, it gives you the last term. In other words, what can you add? So basically here, the next line, this will become minus AB squared. So we'll have two factors like this. This x here will be the first and first here. Now, what should be here and there such that when we add them, we get negative 8. Let me just change the color so that it's visible. We get negative 8. And when we multiply them, we get positive 20. So, for me to get negative 8, I need, first of all, for me to get 20, I know that if I've got 2 times 10, I get 20. Okay? So, but if I need to add these and put the signs, if I need to add this by putting the signs, what are those signs? What are those signs? Adding those two terms so that I get negative 8. So those signs, I can see that 10 must have a minus and 2 must be positive, so that when they are added, I get negative 8, right? So we found those terms. So those terms are actually, so I'm going to delete the question mark. So we found it. So those terms basically is minus 10 and positive 2. So this is the factorization. So we have fully factorized it. Okay, great. Let's go to 3.4. Question 3.4. Now we can solve for x. I'm sorry for the space that I don't have, so I'm just going to try to squeeze everything. So right now we are here. So we are here. So we're solving for x. We're going to solve these two. Can I just use this space here? I think you allow me to use this space. Okay, so this one is 2 marks, right? So what do I have here? Can I just put x on one side? So I have to have 2x. I put it on the left hand side. 19 is on the right hand side. I leave 19. So it's a constant, 19. And I also had another constant on the left hand side. I'm going to move it on the right hand side. So on the left hand side, 1 was positive. When it goes to the right hand side, it becomes negative. So this gives me 2x equals 18. And remember, I have to divide by 2 on both sides. Therefore, x equals 9. Right? So we are done with that. Now the next one. Well, I can just factorize. I can also factorize it. Remember, this left-hand side can be factorized. Is there a common factor? Yeah, there's 4 here, and inside hundreds, I've got the factor of 4. So I'm going to write 4 factor. Here I'm going to get x squared minus 25. But this, I know what it is. This 25 is a square. Is a square of what? Is when 5 is squared, right? So therefore I'm going to get 4x squared minus 5 squared equals 0. Now I've got the difference of 2 squares. It's easy to factorize this factor. So I get 4 factor of x minus 5 factor of x plus 5 equals 0. Now, when my factors is 0, okay, we know that 4 indeed is not 0. But for when you're multiplying quantities like this, for it to give a 0, it means one of them should have been 0. It's either x minus 5. So this factor, which should be equal to 0, or it's x plus 5, which should be equal to 0. And now we can solve individually for each case. In this case, it's either x equals 5, or this is x equals negative 5. So these are the two answers. So here we get two answers. Here we get one answer. So basically here we got one answer with two solutions, which is x equals 5 or x equals negative 5. Okay, so we are done on this page. Let's move on. Let's go to 3.5. 3.5. Study the table below. Okay, what have we got here? What is the first question? Let me just draw the line, because we are competing with space. This screen is just too small to write everything. So 3.1, write down the coordinates of y-intercepts from the table. Okay. What is y-intercept? We know normally we've got a Cartesian plane. Let me draw a Cartesian plane. It's like this. So this will be y-axis. So on both sides, it continues infinitely. And then this side, you have x-axis. So we got y-axis and x-axis. So here they are asking for us to find y-intercept. Y-intercept means, let's say if we've got maybe a curve, just an example. Suppose we have a curve like this. Y-intercept is where this curve intersects with y. In other words, the intersection, that point, that's what is called y-intercept. Or where the curve intercept simply means meet. Where this curve meets y-axis. That's what it means, y-intercept. Now, what does it mean? When something meets y, what will the coordinates of this point be? How will it look like? Okay. It should be easy, to guess that. What we know that all the points on y-axis, they behave in the same way. Let's say you got the point 1 here. You have another coordinate there. You have a coordinate 0. So this is 0, 0. You have another point. You have another point here. So this point, the coordinate here, we know this will be 0, negative 1. This will be 0, negative 2. And this one will be 0, 1. This will be 0, 2, and so on. So what you can pick up is that all the points on y-axis, you see, their x coordinate is always 0. So for you to have a y-intercept, whenever you hear y-intercept, it simply means x should be equal to 0. So let's come back to this table. In this table, we've got the value of x and the value of y. And each pairs gives us basically the coordinate of a point. Like in this case, this produces a pair which is negative 2, negative 5. And now here produces another point which is negative 1, negative 3. But we need to find the point where x should be 0. That's where we'll be having a y-intercept. The only pairs which qualifies, so it's this pair, right? So we can write it. So this is our answer. Write down the coordinate of y-intercept from the table. Well, that coordinate is here, so it should be 0, -1, which is somewhere there. Exactly. So this is the y-intercept we found. Now let's move to the next question. Draw the graph using the table above. Okay. Well, draw the graph. That means we need to have a Cartesian plane. Let me just reduce here. So let me move these sides. I need to draw a Cartesian plane quickly. Let me draw one here. Okay, so I'm going to draw. So this will be my y-axis. And this will be my x-axis. So here we've got point 0. Remember, you can have, let's say, 1, 2, -1, -2, -3, -4. And then we've got -1 here, -2, -3, 1, 2, 3, 4, 5. Okay, right. So what have we got here? Let me just delete this part. Oh no. Let me just, I don't want to delete all the points. So what can I do? I can just use this. Let me just remove this. Okay, so I also have another point here. Let me just write -5, right? So let me plot the first point. So the first point here, there it is. So let me just show you. This is the first point. Right here is -2, -5. So we've got to go to -2. So from the origin, we move -2. We are here. And then -5, so we go down here. Right here. So this is our first point, right? This is -2, -5. Now I'm going to go to the next point. The next point is this one, -1, -3. -1 here. Because we always start with the x coordinate. So along the x-axis right here. And then -3. So we go down. It's here, right? -3. So we plot this point. So this is the point. This is -1, -3. What else have we got? And then we got 0, -1. 0, -1, there it is. 0, -1, right here. And now we've got 1, 1. 1, 1. So we go 1 and then 1 this side. 1, 1. So we're done with this. Now the last one is 2. So 2, 3. 3 is right here. And 2. So this is the next point. 2 and 3. Now we can see that those plots are just, they look what they are aligned, right? So let me just use another color. So if we have to draw them, so normally we use a ruler. So we can actually see that this graph is basically linear, right? So we can draw our line. So they're infinite on both sides. So this line, we were able to draw it by just plotting our table here, right here. So we've done this. We drew the graph using the table above. Now the question, is the gradient increasing or decreasing? Well, we know when we've got a line, remember, how do I know if you increase or decrease? Because, okay, remember when you've got a graph, the positive way is going to this direction. Okay, remember when you go this way, that's where you increase, positive. This way is you decrease, so the negative. So numbers increase going in this direction. So if you see a line like this, so it means you have to climb it. Whenever you climb, it means the gradient is positive. Whenever you descend, if you see a line that is going this way, when you go, because we are moving toward the positive direction, if you move this way, you are descending. So this line here, this has a negative gradient. But this one here, this line here is a positive gradient. Great. So now let's come back to the line that we drew here. Remember, we are moving toward this positive direction. Can you see? It's like we are climbing, right? So it's a positive direction. So if we are climbing, it means it's increasing, right? So the right answer is the gradient is increasing. It's not decreasing, it's increasing. Okay, great. I think we're done with question 3. Now we can move to question 4. Okay, now let me just cut the video and go to the next part.